This is our third lecture of Unit 1 Analytic Functions in the course 19 MA 204 Complex Variables and Ordinary Differential Equations. In this lecture, we are going to discuss about conformal mapping. So before that, what is meant by mapping? In a mathematical technique, we are used to convert one mathematical problem and its solution into another. That is called a mapping. It involves the study of complex variables. In complex variable, the function z equal to x plus iy in the z plane is converted into the function w is equal to u plus iv in the w plane. This process is called mapping. So z plane function is mapped into some other form into the w plane. This is called mapping. So what is meant by conformal mapping? So in conformal mapping is a mathematical technique used to convert or map one mathematical problem and its solution into another. It must preserving both angles and shape, also direction. So it preserves the angle and its corresponding direction is called the conformal mapping. Yeah, of course, both magnitude and sense is called conformal mapping. Magnitude and sense means it preserves the angle magnitude and it's the direction. The necessary condition for conformal mapping is w is equal to f of z represent a conformal mapping of a domain D in the z plane into a domain D of the w plane. Then f of z is an analytic function in domain D. The same domain only mapping will happen. In that particular domain, the function must be analytic. Application of a conformal mapping is a large number of problems arise in fluid mechanics, electrostatics, heat conduction, and many other physical situations. There are different types of conformal mapping over there. We are listed some of the conformal mappings are like translation, rotation, magnification, inversion, reflection. We will see one by one. What is meant by translation? A conformal mapping in which every point in z plane is translated in the direction of a given vector is known as translation. In this particular translation type, we are using the transformation is w is equal to z plus alpha. Z plus something means that comes under the translation category. So let us look how the first problem under this category determine and sketch the image of mod z equal to 1 under the transformation w is equal to z plus I. They are given the sketch in the z plane mod z equal to 1, which is nothing but a unit circle with center 0, 0 and radius 1. So we are using the transformation w is equal to z plus I. We are going to find out the transformation in the w plane, as well as we need to sketch both z plane and w plane transformations. So first let we know that w is equal to u plus iv. So w is nothing but u plus iv, which is equal to here I am going to substitute w and z values. Z equal to x plus iy plus I. Now I am splitting the real and imaginary parts. I will get x plus I into y plus 1. Now I am equating the real and imaginary parts separately. U is equal to x and v is of course y plus 1 is equal to v. So therefore y is equal to v minus 1. We have find x and y value by using the given transformation. After that, I am using this x and y value into the given image in the z plane. They are given image in the z plane is mod z equal to 1. Mod z means what? Square root of x square plus y square. So therefore, after squaring on both sides, I will get x square plus y square is equal to 1. Now I am using x and y values here. X is equal to u and y is equal to v minus 1. After substituting, this represents u square plus v minus 1 the whole square is equal to 1. This looks like a circle with center 0, 1 and radius is 1. So therefore, in the z plane, unit circle is transformed into the circle with center 0, 1 and radius in the w plane. Look at this transformation sketch here. So this circle is in the w plane, this circle in the z plane. In the z plane, we are taking x axis, y axis, and w plane we are taking u and v axis. Move on the next category, rotation. A conformal mapping in which every point on Z plane, let P of x comma y such that OP is rotated by an angle alpha in anti-clockwise direction mapped onto W plane given by W is equal to e power I alpha into Z is called rotation. Here the transformation is W is equal to e power I alpha into Z. So this OP is transformed into, rotated into OQ in the angle alpha. So this is rotation. We are using the transformation e power I alpha into Z. So look at the example under this category. Determine and sketch the image of rectangle mapped by the rotation of 45 degree in anti-clockwise direction formed by is x equal to 0, y is equal to 0, x equal to 1 and y is equal to 2. These are all the image given by the Z plane. So by using this transformation angle, we are going to find out the image of the W plane. So given a rectangle is x equal to 0, y is equal to 0, x equal to 1 and y is equal to 2. Let the required transformation is e power I t. Here angle is 45 degree. 45 means pi by 4 into Z. Look at the general case. The transformation is e power I alpha into Z. Suppose they are given the angle means we need to use this transformation. Here they are given the angle, so therefore I am going to use this transformation. Here 45 degree means pi by 4. Now I am expanding this e power I theta formula, cos theta plus I sin theta. So therefore cos pi by 4 plus I sin pi by 4. Z is nothing but, look at the previous step, Z is nothing but, we know that x plus Iy. Now cos pi by 4 is 1 by root 2, sin pi by 4 is also the same 1 by root 2 into x plus Iy. After multiplying these two, the real and imaginary parts are, because x into this particular one, 1 by root 2 into x, I into I is minus 1. So therefore 1 by root 2 into y. So therefore x minus y by root 2 is real part. So while I am multiplying Iy with this 1 by root 2, I into y 1 by root 2 and x into I 1 by root 2. So therefore I times of x plus y by root 2. After multiplying, split the real and imaginary values. Now left hand side we are having W. W is nothing but u plus iv. So expand this u plus iv and equate the real and imaginary parts separately. U is equal to x minus y by root 2 and v is equal to x plus y by root 2. Now they are given x equal to 0. The first value x equal to 0. In that place I am replacing x equal to 0 in u. I will get u is equal to minus y by root 2 and v is equal to y by root 2. So which gives u plus v is equal to 0. While I am adding these two, I will get u plus v is equal to 0. The second point is y is equal to 0. While I am replacing in uv y is equal to 0, I will get x is equal, u is equal to x by root 2 and v is equal to x by root 2. While I am subtracting, I will get 0. The next point is x equal to 1. In the above equation, I will substituting x equal to 1, I will get this. While I am adding these two, I will get u plus v is equal to root 2. So this also line. The last line is y is equal to 2. Here also, while I am substituting y is equal to 2, I will get like this. After subtracting these two, x by root 2 getting cancelled. At finally, I will get u minus v is equal to minus 2 into root 2. This is also line. So look at these lines. In the Z plane, they are given y is equal to 0, x equal to 1 line is this, y is equal to 2 and this is x equal to 0. This is transformed into the line. So u plus v is equal to 0 means passing through the origin. U plus v is equal to 0 and u minus v is equal to 0 and u plus v is equal to root 2, this particular line, and u minus v is equal to minus this particular line. So this is also rectangle. Rectangle is transformed into rectangle, but here rotation is happened. This line is rotated into OQ line, no? So likewise here also, so this rectangle is rotated like that. This is comes under the rotation category. So come to the next category, magnification. A conformal mapping in which every point on Z plane mapped into W plane given by W is equal to CZ is called as magnification. In this process, mapped shape is either stretched or contrasted in the direction of Z. Look at the first example. Here in this category the transformation is CZ form. Determine the transformation W is equal to 2Z where modulus of Z equal to 2. They are given the Z plane shape is mod Z equal to 2. This is nothing but a circle. They are given the transformation W is equal to 2Z. Given mod Z equal to 2, after expanding this I will get square root of x square plus y square is equal to 2. After squaring on both sides I will get x square plus y square is equal to 4. This represents a circle on Z plane having center 0, 0 and radius 2 units. So now let the required transformation, they are given W is equal to 2Z. Z is nothing but x plus iy. So after expanding W, u plus iv is equal to 2x plus i2y. Now equate real and imaginary values. I will get u is equal to 2x. So therefore from that I will get x is equal to u by 2 and v is equal to 2y. I will get y is equal to v by 2. Substitute x and y value from the above equation, x square plus y square is equal to 4. I will get u square plus v square is equal to 16 in the W plane. This is also a circle with center 0, 0 and radius is 4 units. This is the circle. They are given in the Z plane, which is transformed into the circle in the W plane. U square plus v square is equal to 16. So this preserves the of course magnification is either stretched or contrast, but here there is no rotation or something like the translation like that. It preserves the same shape, but it may be a larger than the given one or smaller than the given Z plane value. Inversion. So in this conformal mapping in which every point on Z plane mapped into W plane given by the transformation W is equal to 1 by Z is called an inversion. So look at the first example. Determine the transformation W is equal to 1 by Z where modulus of Z equal to 1 is the given figure in the Z plane. After expanding this I will get x square plus y square is equal to 1. Now given transformation is W is equal to 1 by Z. Z expansion is x plus iy. So here I cannot able to split real and imaginary part. That's why I am taking the conjugate of x plus iy, that is x minus iy by I am multiplying conjugate of x plus iy both numerator and denominator. Next I am separating. I am simplifying the denominator. I will get a plus a plus b into a minus b is equal to a square plus b square. I will get x square plus y square. So left hand side w value is u plus iv. So now I am separating real and imaginary parts. X by x square plus y square minus I into y by x square plus y square. So now I will get x square plus y square is 1 unit circle they are given, right? So after replacing I will get the numerator value alone x minus iy. Now I can easily split real and imaginary parts. U is equal to x and v is equal to minus y. I'm replacing x and y values. X is equal to u and y is equal to minus v in the given figure. X square plus y square is equal to 1. I will get the circle u square plus v square is equal to 1. Of course in this particular problem Z plane circle x square plus y square is equal to 1 is transformed into u square plus v square is equal to 1 in the W plane. So look at the next example in the same category. Find the image of, they are given the inequality 1 less than x less than 2 under the mapping W is equal to 1 by Z in this type of category. So I'm just rewriting the given this is one way of finding real and imaginary values. Either go for the last problem, otherwise this is also okay. So given transformation is W is equal to 1 by Z. I'm just interchanging rewriting this as like Z equal to 1 by W. Now Z is x plus iy and W is equal to u plus iv. Now I'm taking the conjugate multiplication in the right hand side. I will get u minus iv by u plus iv into u minus iv. Denominator looks like a plus b into a minus b. After simplifying, I will get u minus iv by u square plus v square. Now separate the real and imaginary parts. Real part is x. X is equal to u by u square plus v square, and imaginary part y is equal to minus v by u square plus v square. Take this equation 1 and 2. Substitute this x and y value into the given strip. They are given the inequality 1 less than x less than 2. At a stage I cannot able to find. Consider one side. X is greater than 1. I am considering the first half. X is greater than 1. Here I am replacing x value. U by u square plus v square. Now simplify this. I will get u square plus v square minus u is less than 0. So this is nothing but a circle equation. For better understanding, I'm making this into perfect squares. You just add and subtract 1 by 4. So 1 by 4, I'm combining this into u minus 1 by 2 the whole square plus v square minus 1 by 4, because while I'm opening this I will get u square minus u plus 1 by 4. Plus 1 by 4 minus 1 by 4 getting cancelled, I get back the previous equation. So therefore this is nothing but I'm just moving this 1 by 4 into right hand side. I will get u minus half the whole square plus v square is less than half the whole square. This is a circle with center half comma 0 with radius half. So consider the second half of the given strip. Yeah, of course the above is a circle with center half comma 0 and radius is half. Consider the second half of the given strip. X is less than 2. Here substitute x value and simplify it. I will get u square plus v square minus half times of u is greater than 0. So this is also a circle with center 1 by 4 comma 0 and radius is 1 by 4. For better understanding, make like this. And I'm going to plot this into graph. They are given the strip 0 1 less than x less than 2, which means x is equal to 1. You have to draw the line for x is equal to 1. You must be take the inequalities into equality while you are drawing this sketch. So 1 less than x less than 2 means x equal to 1 and x equal to 2. X equal to 1 line and x equal to 2 line. X lies between these two lines. So therefore this is our region in the z plane, which is mapped into the circle with center 1 by 4 comma 0. So greater than this circle and less than this circle. So this circle center is half comma 0. Greater than this circle means out of this circle. Less than this circle means inside this circle. So this circle, second circle center is 1 by 4 comma 0. So this is the second circle out. Greater than this circle means outside this circle, and this is the big circle is center is half comma 0. Inside the circle is our region. So therefore our region is in between these two circles. This is the mapping in the W plane. In the corresponding Z plane transformation is like that in the W plane. So come to the next category, reflection. A conformal mapping in which every point on Z plane mapped into W plane given by W is equal to Z bar. This represents the reflection about the real axis. So look at this. Transformation W is equal to Z bar, where they are given modulus of Z minus 2 plus I is equal to 4 in the Z plane. We cannot understand what is this, so therefore I am expanding this. Separate the real and imaginary parts. Z equal to x plus iy. So after separating the real part, I will get x minus 2 plus I times of y minus 1 is equal to 4. Squaring on both sides, I will get x minus 2 the whole square plus, after removing and squaring the both sides, I will get x minus 2 the whole square plus y minus 1 the whole square is equal to 16, because x plus iy, modulus of x plus iy is square root of x square plus y square. So therefore in place of x I am having x minus 2, y place I am having y minus 1. Now Again, they are given w is equal to z bar is x minus iy, w is u plus iv. Now I'm finding x and y values. X is equal to u and y is equal to minus v. I'm substituting this into the above equation number 1. I'll get u minus 2 the whole square plus v plus 1 the whole square is equal to 16. Yeah, in the z plane also we are having the circle with center 2 comma 1 and radius is 4. In the w plane also we are having the circle with center 2 comma minus 1, radius is 4. So this is the transformation of this corresponding problem. So this is in the z plane and this sketch in the w plane. Thank you guys.